Welcome to today's episode. Have you ever wondered what powers the devices around us, or what makes renewable energy storage so efficient? Today, we're diving into the fascinating world of lithium iron phosphate batteries, also known as LiFePO4 batteries. From their structure to their chemistry and how they're made, we're covering it all. So let's get started. What exactly is a LiFePO4 battery? It's a type of lithium-ion battery that uses lithium iron phosphate as the cathode material and typically graphite as the anode. These batteries are widely used in electric vehicles, renewable energy storage, and portable electronics due to their high energy density, long lifespan, and safety. What makes LiFePO4 batteries stand out is their exceptional thermal and chemical stability, reducing the risk of overheating and ensuring consistent performance over thousands of charge cycles. Their robust design makes them ideal for demanding applications. Let's break down the main components of a LiFePO4 battery. Cathode, made of lithium iron phosphate, LiFePO4, storing lithium ions when the battery is discharged. Anode, often composed of graphite, storing lithium ions when the battery is charged. Electrolyte, a liquid or gel that allows lithium ions to move between the cathode and anode. Separator, a thin porous membrane that keeps the anode and cathode apart while allowing ions to pass. Current collectors, thin foils, aluminum for the cathode and copper for the anode, conducting electricity to and from the battery. Each component plays a critical role. Together, they enable efficient energy storage and discharge, which is essential for powering our modern world. Now, let's explore how these components come together in manufacturing. Here's how a LiFePO4 battery is made. Material preparation. Lithium iron phosphate is synthesized by mixing lithium carbonate with iron and phosphate precursors under high heat. This process ensures a stable cathode material with consistent properties. Coating and drying. Cathode material is coated onto aluminum foil, and graphite is coated onto copper foil. Both are dried to remove solvents and achieve a uniform layer critical for performance. Electrode cutting. The coated foils are cut into precise shapes for battery cells, ensuring consistency and minimizing waste. Cell assembly. The electrodes are layered with a separator and wound or stacked into a cylindrical or prismatic shape, depending on the battery design. Electrolyte filling. The electrolyte, a carefully formulated solution, is injected into the cell to facilitate ion movement. Sealing and formation. The cell is sealed to prevent contamination and cycled several times to stabilize its chemistry and verify performance. Every step in the process is crucial. Even small deviations can impact the battery's capacity, safety, or lifespan. How does a LiFePO4 battery work? It's all about lithium ions. During charging, lithium ions leave the cathode and move to the anode, where they nest in the graphite structure. During discharging, ions move back to the cathode, releasing energy stored during the charging process. The strong bonds in the LiFePO4 crystal structure ensure stability, improving safety and lifespan compared to other lithium-ion chemistries. Additionally, this structure supports high current delivery, allowing these batteries to handle demanding applications without compromising reliability. LiFePO4 batteries are making a difference in various fields. Electric vehicles, or EVs. Their safety and longevity make them a top choice for EVs, ensuring a smooth and reliable driving experience over years of use. Renewable energy storage. They efficiently store power from solar and wind systems, helping to balance energy demand and supply, especially during peak usage. Portable electronics. From power tools to medical devices, these batteries are trusted for their durability, reliability, and high performance. Advantages include high cycle life, low maintenance, and eco-friendliness. Unlike other lithium-ion batteries, LiFePO4 batteries do not contain heavy metals like cobalt, making them a greener alternative with reduced environmental impact. Furthermore, their thermal stability means they are less prone to overheating, making them safer for a wide range of applications, from homes to industrial use. And there you have it, a detailed look into the world of LiFePO4 batteries. Their robust design, safety features, and eco-friendly nature make them a cornerstone of the renewable energy revolution and a reliable power source for countless applications. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell. Thanks for watching, and I'll see you in the next one.